Hello everyone, I am Avinash Survase, a research scholar working in Department of Microbiology, Rayat Institute of Research and Development, Yashwantrao Sawan, Institute of Science, Satara. Today I am going to deliver my poster presentation on green synthesis of titanium dioxide nanoparticles for textile methylene blue dye degradation. There are various techniques used for synthesis of nanoparticles like physical method, chemical method, and biological method. Biological method is a similar approach to chemical synthesis method, but instead of chemical reducing agent, we use biological sources for synthesis of nanoparticles. Biological method is a green approach for synthesis of nanoparticles in which microorganism or plant phytochemicals is used as reducing agent, stabilizing agent or capping agent. Microorganism or plant phytochemicals are reacted with metal salts. These metal salts converted into metal nanoparticles. These metal nanoparticles further purify and characterized by various biophysical techniques. Biological synthesis method in which we use microorganisms because microorganisms are considered as potential biofactory for synthesis of nanoparticles. Yeast, bacteria, and fungus are used for synthesis of nanoparticles, but instead of yeast and bacteria, fungi secrete large amount of enzymes or inorganic nutrients either intracellularly or extracellularly due to we choose fungal culture for synthesis of titanium dioxide nanoparticles. There are various advantages using biological methods like to avoid toxic chemicals, to form economical viable nanoparticles, to produce eco-friendly nanoparticles, to control size shape of nanoparticles with the help of modifying pH, temperature, concentration of salts and nutrient media. In experimental procedure, we use serial dilution techniques for isolation of fungal culture. Isolated fungal culture was purified with the help of four-quadrant method. Pure culture of fungus is inoculated into saprolite dextrose broth and growing culture about 48 hours. This growing culture cell-free extract was challenged with titanium chloride salt. This cell-free extract converted TiCl3 into TiO2 nanoparticles. These TiO2 nanoparticles further characterized by various biophysical techniques. When you synthesize any metal nanoparticle, the first step of characterization is UV visible spectrophotometer. Color changes from violet to white precipitate form indicates that the formation of TiO2 nanoparticles. The maximum absorbance spectra is about 214 nanometers indicates that formation of TiO2 nanoparticles. Fourier transform IR spectroscopy used for the identification of functional group in involvement of capping and stabilization of nanoparticles. We observe six distinct peaks in the FTIR spectrum. 3434 centimeter inverse spectra indicates that NH stretching present in peptide linkage present in fungus and TiO2. X-ray diffraction technique used for identification of size, shape and nature of nanoparticles. With the help of XRD data, we concluded that we synthesize pure anatase tetragonal shape of TiO2 nanoparticles. We use Debye-Scherrer formula for calculate the crystallite grain size is about 33.89 nanometers. We use field emission scanning electron microscopy technique for observing 3D nature and morphology of nanoparticles. We observe with the help of efficient spherical nature of TiO₂ nanoparticles having range below than 50 nanometers. Biologically synthesized TiO₂ nanoparticles used for further applications like dye degradation and antimicrobial activity. We use textile dye methylene blue for application of TiO₂. Biologically synthesized TiO₂ effectively degrade methylene blue textile dye within 60 minutes, about 91%. With the help of decolorization percentage formula, we conclude about 91% of methylene blue dye is degraded by TiO₂ nanoparticles under visible light conditions. Biologically synthesized titanium dioxide nanoparticles used for antimicrobial activity against 3 pathogenic strains like Staph aureus, Salmonella typhi, and Proteus vulgaris. TiO₂ nanoparticles show excellent antimicrobial activity against Salmonella typhi. In conclusion, we concluded that we biologically synthesized TiO₂ nanoparticles with using isolated fungus Aspergillus eucalypticola SLF1. Biologically synthesized nanoparticles is spherical in nature, having 33 nanometers in size. Biologically synthesized nanoparticle effectively degrade 91% of methylene blue dye. It is a textile dye within 60 minutes and antimicrobial activity against 3 pathogenic strains like Staph aureus, Salmonella typhi, and Proteus vulgaris. Biologically synthesized nanoparticles having multiple applications used for effective dye degradation. Authors are thankful to CSIR UGC New Delhi for awarding JRF Fellowship and PG Department of Microbiology Yashwantrao Sawan Institute of Science Satara for conducting this work. Thank you.